Hi everyone. In this video, I'm going to walk you through a more complex example of doing a line balance. Let me share my screen. People will typically talk about completely linear lines when they're talking about line balancing. And oftentimes when you're doing it on paper, the recommendation is that you balance every feeder line independently and then try to bring them together. But in this example, we'll see how we can balance this whole line in one go. So the first complication in this example is that there are multiple feeder lines that come together to build the final product. The second complication is essentially that we have two units being built in line A. Two of those go in to complete one build overall. The third complication here is that as you'll see over here, there are a bunch of machine steps. Specifically, the operator places a sensor module in a piece of testing equipment. Then he or she starts the testing equipment. The testing happens. It's happening in parallel to whatever the operator is doing. The operator doesn't need to stand next to the machine. They can go and do other things while the machine is doing completing the test, and then they'll take out the tested unit out of the piece of equipment. And one thing that I've done so that we can keep this video relatively compact is that I've uh, built this line a little bit simply. Really, all of these A, B, C, and D, they're not. They are basically just individual stations. All right, so here we are in Kaizen Copilot. As you can see, I'm in the line balancing module, and I've already set up the line that I sort of set up I'm beginning to set up the line that I showed you in the slide. Essentially, you can see I went into each of those stations, put a smartphone up, captured a cycle inside of station design, and then as usual, I'm doing a rebalance in underline balancing. I added these four stations that are already in here now. Uh, Imported them, and now I'm going to do what you need to do to actually model that the more complicated facets of the line that I described earlier. The first thing I'm gonna do is you'll notice that in fact when you're adding a line, it asks you adding a new station to this line. The system does ask you about the pieces per cycle that are being built, right? And typically you leave it at, if it's single piece flow, you will leave it at one. Uh, and you can see that for station number one, it says pieces per cycle is set to one right now. For station number, station C, it's the same case. It's station B and station D. It's the same. But if you'll recall, station number A needed to produce two units of the sensor module so that the overall line could build just one unit. So really what's happening in the station number A is we are producing half. Every cycle is really producing just half of half of the units that are needed to build the overall unit, right? Station A is I will go into edit and I will specify pieces per cycle as 0.5, right? The reason again being that in one cycle of what we had observed on station A, one cycle is really producing half of the required parts for the overall output of this line, right? So everything else is producing one piece. All right, so now that we have modeled the first piece of the puzzle, which was the fact that station A is only producing half pieces per cycle, we will try to model the second piece, which was that station A has a bunch of steps that are actually machine steps. So what I'm going to do is I'm going to click on this. I have selected station A, and I will click on edit actions for station A. Now, if you go down, you can see that there is this button, there's this drop down menu that allows me to select specify a type to each action, right? When we were just doing time study in station design, it didn't really matter. So there we didn't ask you for whether this is a manual or machine action, but by default, all the steps for all the stations are labeled as manual over here. And what I'm going to do here is, by the way, I can hover my cursor on this action types, and it defines the action types that are available. We have, of course, manual available, but there's also a machine auto step. Machine auto steps are steps that can be operated independently without requiring an operator intervention, such as pressing, welding, drilling. Whereas there is this step type, which is machine manual. And these are machine manual tasks are typically tasks that are needed to load the machine, basically load or unload the machine, to set up a machine before a machine auto step can take place, right? Machine manual are basically manual tasks that are required, that you need to perform before the machine auto step can take place, such as setting up the machine, or then afterwards, after the task is complete, unloading the machine, right? So let's specify that. The first step, okay. Okay, so this is the machine step in the quality tester. Place the sensor module in the quality tester. It's really a machine manual step. The next is start sensor module test. So basically you're clicking a button. We will also choose it, specify it to be machine manual, but then the sensor module test is actually taking place, which is happening automatically. And I'm going to select machine auto, which will mean that it can be done in principle in parallel to what the human is doing, in parallel to whatever the human does. And then finally, you have remove tested unit, which I select also as machine manual. I will save this. And this basically, at least now, the system knows which steps are machine manual and which steps are machine auto, right? Now we are going to the next page, and now we are going to uh, specify that feeder line kind of structure into the system. I click on next, and we are going to do that by setting predecessors for every step appropriately. Specifically, for station A, basically we will, in fact, let me start by clicking on autofill chronologically. This will make our lives a little bit easier to have, for every step, when I click on this, every step just gets filled with a previous step as its predecessor. So the system assumes right now that to complete step number 3, step number 2 must be completed. To do step number 4, step number 3 must be completed. That's what it means to have 3 here. If I just put 1 in here, that would mean that to complete step number 4, I need step 1 to be completed, but 2 and 3 doesn't have to be complete. And step 4 could be done in parallel to step 1. Anyways, for station 1, things are pretty much sequential. There is going to, I'll come to the machine auto and machine manual steps in a second, but let's represent the other branches in this line, the other feeder lines. Essentially, clean protective lens, the top of the of line C, that doesn't actually depend upon 8, does it? It doesn't depend upon anything. You can start that without worrying about any step to be complete, right? Just look here. This was station C or line C, and clean protective lens. You can just start this without worrying about any other step. And then, you do step number 2 for which you do need the earlier step, clean protective lens, to be complete, and so on. Similarly, in step B, in station B, inspect control housing doesn't require anything to start. So let's model this subline B and subline C. So for C, I've selected no predecessors here, but for subsequent steps, yes, apply labels to lens does require that the protective lens is cleaned, and moving lens to module attachment jig does require that the apply labels to lenses is already complete. So that's why I put in 10 here, and so on. Now, similarly over here, this is the top step. First step, inspect control housing of station B, and we don't need anything here. This step doesn't require any other step to be complete for us to start this step. And then, otherwise it's pretty sequential. Now we get to station number D, and let's just quickly check what station number. So station number D, right now it says that for step number 18, this attach and secure control housing step to start, we need step number 17 to be complete, which is remove control housing from jig. Okay. What else do we need? What else do we need for this step to be, for us to be able to start this step? This is this step, right? On station B, attach and secure control housing. Yes, we need to remove control housing from jig, but we also need the mount lens on jig step to be completed for this step to start, right? Mount lens to jig. There are two steps that are going into this one. One is remove control housing from jig, and the other is mount lens on jig. So we will have to put in both of these numbers in for this step, attach and secure control housing. So this is attach and secure control housing. We already have step 17 in here. Let me check and the mount lens on jig, which was the last step of station C. This is step number 12. Let's put 12 in here as well. Great. So then you have this uh, attach and secure two sensor modules step that is also in station D. There are also two, this is, yes, it's dependent upon step 19 being completed, but it's also dependent upon another step, which is the last step of station number A. Well, actually, this send test, yeah, last step of this. This is 8. Send tested sensor module to work in progress. So 8. So I'm going to put in 8 here. So this step really depends upon both 19 and 8. As you can see here, right? So this is the third step of station D. So these are the 4 steps that are on station D. And the third step here requires both this step, which was numbered as step 8, send tested sensor module to WIP, as well as attach and secure central support ring. And we've put both of these in. So this basically means that the line is more or less complete. I'm going to save it. And then I click on generate results. Now, this brings me to another concept uh, that is related to machine auto-like steps. The thing is, right now, the way we have specified this process, it's what we call product flow. Product flow means that product flow is more from the perspective of what happens to the product as it's being built. Let's go back to the original line and how it's described. So this is line A. So basically the sensor module is built. It goes into the ultrasonic press 3000. The operator operates the ultrasonic press and removes the finished sensor module. Since it's only a manual step, we keep it manual. There's no automatic step, so we didn't need to label it as machine manual. But then we get to this, right? So once you remove the ultrasonic press, once you remove the finished sensor module from the ultrasonic press, you put it in the quality tester, right? And then you start the module test, or from the perspective of the product, you start the model test, and then you perform the sensor. You actually run the test, and then you remove the tested unit, and then you send it to the whip. But this would be a strictly sequential way of doing it. In reality, what one can imagine what will happen when you're doing it, when you're actually performing this step, this will be happening in completely automatically. The perform sensor module test will be happening automatically. I think it's a 35-second long step, and as this step is taking place, the operator is free to do other things. So in practice, what the operator will start doing is operator will start building the next sensor module, right? And by the time this test is done, the operator will already have the next sensor module finished. So in reality, what will happen, what is called worker flow, is that the first thing operator will do after, in every cycle after the first cycle, is he or she will be removing the tested unit. So really what should happen is this step should be at the top of the machine steps, and really the machine manual steps, and the machine auto step actually belongs at the bottom, because that is how it's going to be uh, from the perspective uh, of the operator. That's what the operator is typically going to be doing. He's going to finish a sensor module. When he finishes a sensor module, he will first the previous sensor module test will be complete. He will be removing the tested unit. Then he will place the other sensor module that's in his hand. He will start the sensor module test. This will be happening, and in the meanwhile, he's going to put the tested sensor that was already in his hand into the whip, right? This is something that we have built into the software. So uh, once the software detects that you've specified some of the steps as machine auto, it will automatically ask you whether you really want product flow, which means that in the SWCT chart, nothing will be happening in parallel to that machine auto step, right? Because the operator really, to do the next step, the operator has to wait for this step to be complete. But in practice, what typically happens is operator flow, which is that you are doing the machine auto step. The actual testing, when it's taking place, it happens in parallel to other things that the operator is doing, right? So what the software is recommending you to do is that you should really have this. You should really organize the steps in operator flow instead of product flow. And if I just choose this, it will automatically shuffle those, make that minor shuffle. It will shuffle out, basically take that remove tested part and move it to the top of the machine steps, and that's it. And that will really make the system recognize that this machine auto step is happening in parallel. If we had already entered the step names in operator flow order, then it would this pop-up wouldn't have appeared, and you would have already gone to the next screen. It's only because the system notices that there is a machine auto step. You're actually setting up a machine, there is a machine auto step, then but if you do it that way, then the operator still has to wait, whereas in reality, usually when the machine auto step is taking place, the operator starts building the next unit, right? So that's why it's recommending this to us. Let's click on next. Let's get to the generate results page. Okay, so let's see what happened. First of all, this is the precedence diagram that has been generated. This is the main line. Uh, this is the or line A. This is what happened with the shuffled around step. Perform sensor module step is taking place in parallel. Uh, so it's a little bit harder to draw it in a precedence diagram format. But then you see this is your station B, station C, and this is your station D, essentially. Let's look at the line balance itself. We see that this is your sensor. This is basically your station A. I can click on this, and then it shows me this is the purely manual time at the bottom. This is the purely machine time, and this is the overlap time where the human and the machine are overlapping in time. All the others are purely manual time only. Okay. We're producing 42 parts per hour. This is your line balance efficiency, blah, blah, blah. This is your Yamazumi chart. Fine. And then this is your SWCT chart. Here you really see that this perform sensor module test is in fact taking place in parallel to a bunch of other steps, right? Also, by the way, keep notice that the system has understood that it has to build two of these units, two of the sensor modules on station A that will be fed to the rest of it, right? So it's really trying to build two of these. The duration of every step has been multiplied by 2. Uh, so this is exactly what I would have expected, uh, that steps are being done in parallel. Of course, it will depend upon the length of the machine auto step duration as well. Uh, some things will change based on how much parallelism can be obtained. If this was exactly the amount of time that the manual steps took, then we won't have to wait any extra amount of time for the machine to complete its processing at all. Right now we do, because we are still doing, at the end of the day, single piece flow. By the way, in line balance, uh, you will see that this is the station level time. So this basically represents the overall time that this station takes per cycle. Whereas which basically, like we saw, it includes the machine time, manual time, the machine time, and the overlapping time. Whereas if I choose operator only, then you see that really this doesn't really have that much of operator time spent on this at all. It's really some amount of time that's just machine only, where the operator still ends up having to wait for the machine. Let's try to quickly rebalance the line. So what will happen if we have to, if the parts per hour, the volume has to go down, right? What if the volume per hour needs to become, I don't know, 30 instead of 42, right? What will happen? Target cycle or target parts per hour. Okay. So this is how your line will look like. If your target is much lesser, you can run the line with just two operators. And this is how it would be working. Because I believe in this case, the first operator does have uh, other things to do. We are not wasting that, the first operator doesn't have to just wait for the machine to finish testing uh, the second part. They can do other things while the machine is processing. So true parallelism can be achieved, and that's why you are able to just run the line with just two operators in this case. All right, I hope that was helpful. We covered a lot of ground today. Specifically, we learned how to build more complicated kind of lines, lines that have multiple feeder lines coming in, lines that have multiple machine steps, machine auto steps, in even lines where the rate of production is different between the different feeder lines. I hope this helps. Thank you.